Good day, student. My name is Salma Nangula Makili. I'm your new tutor for natural science and health education 2. So my contact details are 081 4986 908, and my email address is salmanangolatoivo@gmail.com. I would like to welcome you to the exam-based contact session for 2020 for the NSHE2. I would like to welcome you, and I wish you all the best in your studies. I want you to be focused, work hard so that you can achieve what you want to achieve. Student, I would like to take you through the tips on the preparation for the examination. And this syllabus consists of a huge content, and I'm only going to highlight some very few important points, not necessarily the ones that are going to come into the examination, but just a scope that will help you prepare yourself for the examination. And when you are preparing for the examination, please make use of your study guide, make use of the prescribed textbooks, and also the physical science ordinary level grade 12 NANCOL modules. There are 3 modules that you can make use of. Okay, to begin with, I want us to look at some of the objectives in the syllabus, not in the syllabus, but in your study guide. And these are not in any particular order. The first thing that I want to look at is the student should know the difference between speed and velocity. The topic of speed and velocity, you should know the difference between the two. As for example, in terms of their definition, the unit of measurements, and also to distinguish between in terms of scalar quantity and vector quantities. And also know the difference between those two terms, vector, what is a vector quantity, and what is a scalar quantity. Also, under the same topic, you should be able to calculate speed or velocity. Remember, these two are the same. There is only one difference that distinguishes them. So know the formula for calculating speed or velocity, and also the unit of measurement. Okay? Then, learners or students, you should be able to define acceleration and also how to calculate it. On the speed time graph, identify the part of the graph, the gradient of the graph that represent acceleration, and also be able to calculate total distance from a speed time graph. And many of you students, you make mistakes here when you're asked to calculate speed, not speed, but total distance on the graph. You normally use distance is equal to speed divided by time, which is wrong from the formula of speed. But when it's on the speed time graph, you should calculate total distance traveled using or by looking at the shape of the graph and identify the shape, and then use the formula for calculating the area of that shape which is formed under the graph to calculate total distance. So please do not make any mistake to use the formula for calculating velocity or speed. Okay, then we move on to the difference between mass and weight, and also how to calculate weight from mass. So here we have a lot of differences that differentiate these two terms, mass and weight. So you should know them, know the unit of measurements, in which unit mass is measured and in which unit weight is measured. also know the instrument of measurement. What are the instruments that we use for measuring mass, and what are the instruments that we use for measuring weight? And in addition to that, you should be able to calculate the weight of an object from its mass. We use that formula: weight is equal to mass divided by gravitational field. So that is the formula that you can use, and then also know the unit in which weight is measured. Okay, then comes to density. Should be able to define density. With density, there are a lot of things involved. You should be able to describe how to measure the density of liquids. That's one. We should also be able to describe how to measure the density of a regular shaped solid, and also how to measure the density of irregular shaped solid. So those three, they fall under density. And also know the formula for calculating density. It's very important, and also its unit. Okay? Then the other thing is moment of force. Students should be able to define the term moment of force, and also be able to use the formula to calculate moment. And again, you student, you should be able to tell when a body is at equilibrium. That's when the clockwise moment and the anti-clockwise moment are equal. So when you calculate moment on the anti-clockwise and you calculate the moment on the anti-clockwise, and they give you the same value or the same answer, that means the body is at equilibrium. Differentiate between moment and work. It's almost the same as the difference between speed and velocity. One is a scalar quantity and the other one is a vector quantity. So know the difference between moment and work in terms of their definition, and also be able to identify which one is a scalar quantity and which one is a vector quantity. With moment, if you are to get the difference between moment and work, moment is a vector quantity, because a vector quantity is a quantity that gives us the size and direction. And just like speed and velocity, velocity is a vector quantity because it shows us the size or the magnitude and the direction, while work it's a scalar quantity because it only gives or shows us only one thing, which is the magnitude or the size, but not the direction. Sources of energy. You should be able to state the sources of energy, and also be able to describe the advantages and disadvantages of each source of energy. Describe the terms and the formula for kinetic and potential energy. Describe what is kinetic energy, and also be able to describe potential energy and to give their formulas. For kinetic energy, when you are calculating kinetic energy, we use that formula. Kinetic energy is equal to half times mass times velocity squared. And for potential energy, when you are calculating it, you use the formula potential energy is equal to mass times gravity times height. So those are the formulas that we can use, but remember, be able also to explain or to define them. The next thing is extension. We should be able to define or to explain the term extension, and be able to interpret the extension load graph. When the load is directly proportional to the extension, or when the limit of proportionality is reached. Then we move on to pressure. Pressure, student, you should be able to define the term pressure and also give the formula for calculating pressure. And in addition to that, also know the factors that affect the liquid and the atmospheric pressure. So with liquid pressure, we have factors that affect it, which are the depth of the liquid, the density, and also the density of the liquid. So those are the factors, some of the factors that can affect the pressure of the liquid. And so you read in your textbooks and also in the modules that I have just stated, you will find that there are so many factors that affect the liquid pressure and also atmospheric pressure. With atmospheric pressure, some of the factors that affect atmospheric pressure is the height above the sea level, which is also known as altitude. So read and know those factors. Then the next thing is the methods of heat transfer, which are conduction, radiation, and convection. So we should be able to describe the everyday applications and the consequences of each of these methods. What are the everyday applications of conduction? What are the everyday applications of radiation and convection? And also the consequences, the problem that might occur for each of the methods. Again, under the method of heat transfer, we should be able to describe good and bad emitters of heat radiation. This have to do with the colors, which can give out heat energy most and which can give out heat energy the least. Then be able to describe the surfaces which are good and bad absorbers of heat radiation. We know that black is a good absorber of heat radiation, and white or silver surfaces are bad absorber of heat radiation. So know how to describe those good and bad emitters of radiation, and as well as good and bad absorbers of radiation. And also know their application. What are their application in everyday life for good and bad absorbers of heat radiation? Okay? Then we move on to pulse. This is the topic of waves. So students, you should be able to define what a pulse is, be able to define what is an oscillation, and be able to define what a wave motion is. And also know the types of waves. For example, we have two types of waves, which are transverse wave and longitudinal wave. So also know the example of transverse wave. And remember, all the electromagnetic waves are example of transverse wave. We can talk of radio wave, microwave waves, and we can also talk of gamma wave, X-ray. All those that we find on the electromagnetic spectrum are example of transverse wave. And example of longitudinal wave, we have sound wave. And in addition to that, not only the types of wave that you need to know, you also need to know the difference between the two in terms of their definition. What is a transverse wave and what is a longitudinal wave? The other thing that you need to know is the properties of wave. Every wave, it can be a transverse wave or a longitudinal wave, have those properties, which are the period of the wave, the amplitude of the wave, the wavelength of the wave, and the frequency of the wave. Those are the properties. and also be able to show some of these properties on the wave graph. Which one is an amplitude on the wave diagram, which one is a wavelength on a wave diagram, and also be able to calculate the frequency and also speed of a wave and the wavelength. We should also be able to define reflection, refraction, and diffraction of a wave. All the waves can be transverse or longitudinal wave, can undergo reflection, can undergo refraction, and they can also undergo diffraction. So what is the reflection of a wave? What is the refraction of a wave? And what is the diffraction of a wave? The law of reflection, it applies in all types of wave reflection. It can be water wave or light wave. The law of reflection applies, and we should be able to draw the diagram and indicate the angle of incidence, the angle of reflection, the incident wave, the reflected waves, and also the normal line. They all comes under the reflection, and you should be able to show the law of reflection on the diagram. Then when it comes to diffraction, you should be able to calculate the refractive index of every material, because every material have got its own refractive index. Be able to calculate it. And when it comes to the diffraction, we should be able to describe which gap, a smaller gap, between a smaller gap and a bigger gap, which one do the most diffraction of the wave. Then we come to magnetism, electricity and magnetism. We should be able to state or describe the properties of magnets. All the magnets can be permanent or temporary. Magnets have got properties. What are those properties? We should be able to describe them. And also be able to describe the concept of magnetism in terms of molecular magnets. For an object or for a magnetic material to be attracted by a magnet, what will happen to those molecular magnets, also known as the dipoles? What will happen to them when an object or a magnetic material is attracted to the magnet? And what will happen to these molecular magnets when the magnetic material is taken away from a magnet? Distinguish between the magnetic properties of iron and also of steel. We all know that magnets are either made from steel or from iron, and this depends on whether it's a permanent magnet or a temporary magnet. For example, all the permanent magnets are made from steel. The reason being because it keeps its magnetism for a longer period of time. And the temporary magnets are made from iron, because iron does not keep its magnetism for a long period of time. And remember, this magnetism that is kept, it refers back to the molecular magnets. Then static electricity, be able to distinguish between static electricity and electric current in terms of their definition, and be able to state the phenomena of lightning, how lightning takes place. And remember, static electricity have to do with charges. So therefore, the phenomena of lightning is also have to do with charge. When a charged object, discharge, the movement of charge from a discharged object, from a charged object to the other object. differentiate between AC current and DC current, alternating current and direct current, and also be able to give the difference between electron current and conventional current. With alternating and direct current, you should also be able to state their sources. Where do we get alternating current and where do we get direct current? Then electron and conventional current, you should be able to show the direction in an electric circuit is either from positive to negative or from negative to positive. And when you are showing them on the circuit, you should use arrow because it is an arrow that shows the direction. Compare potential difference of series and parallel circuit. Here we should be able to give the difference between the two types of circuit, between a series circuit and a parallel circuit. Normally we give the difference in terms of the movement of charge in the circuit, that in a series circuit, or in terms of the movement of charge, and also in terms of the how components are connected. For example, in a series circuit, we describe that it's a circuit in which current have only one way to flow. That means if current have got only one way to flow, is when these components are connected one after the other. In a parallel circuit, this is a circuit where current have got more than one way to flow because they are branches. Current have to get at a junction, at a certain junction, and then divide. Okay? Also, be able to calculate potential difference in a series circuit, because it is in a series circuit where potential difference or voltage differs, and be able to calculate the amount of current in a parallel circuit, because that's where also it differs. While in parallel circuit, potential difference is the same at all the points. Therefore, there's no need for you to calculate it. The potential difference from the cell or from the source will be the same potential difference that will be distributed to the components in the circuit. So it's the same at every point in parallel circuit. But for series circuit, it differs. The same with current. In series circuit, current is the same at all the points. Therefore, you don't need to calculate current in series circuit, but you need to calculate, or you need to know how to calculate it in a series, not in series, but in parallel circuit. Then come to resistance. Know how to define the term resistance, and the formula for calculating distance, how to calculate resistance in a parallel circuit, and also how to calculate resistance in a series circuit. Also be able to identify the factors that affect the resistance of a conductor, of any conductor, because wherever we have a flow of charges, there must be resistance. Now, what are the factors that affect the resistance of the conductor? You should be able to describe them as the length of the conductor. So that's one factor. Then you should also be able to describe how that length of a conductor affects the resistance. The other factor that you should be able to describe is temperature. Temperature is the second factor that affects the resistance of the conductor. Then again, be able to describe how temperature affects the resistance of the conductor. The other one is the cross-sectional area of a conductor, also known as the surface, the surface area, cross-sectional area of a conductor. How does it affect the resistance of the conductor? Also the type of material, because different material conduct electricity differently. due to the resistance. Some have got higher resistance and some have got low resistance. Now, be able to tell which ones have got low resistance and which one have got a higher resistance. And in addition to that, know that materials with higher resistance, the amount of current that is going to pass through them is also it's going to be low. Because resistance is the opposition to the flow of charge. So if the resistance is high, then the amount of current that is going to pass through there is going to be little. And when if a material have a low resistance, that means the amount of current that is going to pass through them or to pass through it is going to be more. So now, which one are best to use? Is it the material with a low resistance or materials with a higher resistance? Remember that at the end what you want is current which is passing through them. Now, which one are good to use in the, for example, in the circuit or in electrical appliances and all that? Again, in addition to that, you should be able to sketch a voltage current or current voltage graph for ohmic conductors and non-ohmic conductors. But before that, you should be able to know the difference between the two. What is an ohmic conductor and what is a non-ohmic conductor? Material that can conduct electricity, well, called ohmic, and non-ohmic are those material that do not allow, or they do allow current to pass through them, but with difficulties. So then you'll be able to sketch a graph of voltage against current. Now, for an ohmic conductor, the graph is going to be a straight line from passing through the origin. And for the non-ohmic conductor, it's still a straight line through from the origin, and it will start to curve upward. So that is the difference between the two graphs. A straight line graph from the origin that shows the current that is passing through an ohmic conductor, and a straight line from the origin and start curving up toward the end, that is a graph that shows current passing through a non-ohmic conductor. Also know the term background radiation. This is a topic of radioactivity. We should be able to describe the term background radiation and also be able to identify the types of radiation emitted. For example, here we are talking of the alpha particle, the beta particle, and also the gamma rays. So those are the types of radiation. Also, be able to describe their characteristics. What are the characteristics of these three particles? For example, for alpha, we call it a helium nucleus because its nucleus is exactly like that one of helium, an element in group 8 of the periodic table. And beta, it's called, or it's referred to as an electron because it only have electrons, no protons which are positively charged. What we find there is only electrons which are negatively charged. And then also gamma, the nucleate notation for gamma, it doesn't have any mass number. It doesn't have the protons or the neutrons. So we have 0, 0 there, no mass number and no proton number, neither the neutron number. Also, in addition to that, know the ionization effect. These are some of the characteristics of these radioactive types. So also know the ionization effect of each of the particles. Also know the penetration power. Which one can penetrate most and which one can penetrate through an object or through a material least. Okay, then characteristics of, that's what I've been talking about. Then be able to describe the half-life when these radioactive particles are decaying. Be able to describe what is a half-life, also how to present it on the graph, or how to determine the half-life from the graph. And other thing is the periodic table of atom. This one we are familiar with it. The periodic table, you should be able to describe what it is. You should be able to describe the metals and non-metals in the periodic table, which ones are the metals and which one are the non-metals. Also know which group in the periodic table are referred to as the alkali metals, which one are called the alkali earth metals, which ones are called the transition metals, and which one are called the halogens, and which ones are called the noble gases. These are the special names given to some of the groups in the periodic table. So know which one is which. Okay, also with the periodic table, you should be able to describe the relationship between the atomic structure. When you are drawing the structure of an atom, be able to describe what is the relationship between that structure and the periodic table. For example, you should be able to describe that if an atom, the structure of the atom that you are drawing, if that element is in the period 1, it's going to have one period. That's the relationship. That means the number of the number of shells around the element are equal to the number of period. Those elements in period 1, they all have one shell. Those elements in period 2, they are all having 2 shells. Elements in period 3, they all have 3 shells. So that is the first relationship between the atomic structure and the periodic table. The other one is the connection between the number of electrons on the outer shell of an atom and the group number. So the relationship is that the number of electrons on the outer shell are equal to the group number. So those elements in group 1, they have 1 electron on the outer shell. All those elements in group 2, they have 2 electrons on the outer shell. Group 7, they have 7 electrons on the outer shell. Okay. Then we move on to the topic of organic chemistry. Here you should be able to know the concept of homologous series, what it is, and what are the members of the family of homologous series. For example, we have the alkanes, have the alkenes, and alcohol, etc., etc. Now, these members of this homologous series have their examples. For example, members of the alkenes, you should know them: the methane, the ethane, the propane, and all that. Members of the alkene, you should know them. Members of the alcohol, you should know them. And together with that, you should also be able to know their structural formula, and also the boiling point of these members of every group. How does the melting point and boiling point changes as the number of carbon and hydrogen atom increases? As the chain increase, what will happen to the boiling point and the melting point? Okay? Then we should be able to differentiate between saturated and unsaturated hydrocarbons. Saturated and unsaturated hydrocarbon. And when you are talking of saturated hydrocarbon, we are talking about the alkenes. And you should know the reason why alkanes are called the saturated. It's because if you are to go back to their structural formula or their properties, let me talk about their properties. If you are to go back to the properties of alkanes, we said alkanes have got a single bond between them. Between all the carbon-carbon atom, there is a single bond, and that single bond is represented with a single line. And that is what makes them to be saturated. It's because of the single bond which cannot be broken and allow other atoms to join on the chain. And unsaturated hydrocarbon, we are talking about the alkenes. Why are they called unsaturated? It's because of the double bond that is found between two carbon atoms in the chain. Remember that double bond, no matter how many carbon atoms are there, is only found between two carbon atoms. So now, the reason why they are called unsaturated, remember, is that that double bond can be broken and create new single bond where other new atoms can attach to the chain. So that is the difference between saturated and unsaturated hydrocarbon. And remember, when you are talking of them, we are referring to the alkane, saturated, and the alkene, which are unsaturated. Now, how do we differentiate between them? Suppose we are given two beakers containing the two compounds. How can you tell that this is a saturated hydrocarbon and this one contains an unsaturated hydrocarbon? Remember, we use the solution which is known as a bromine solution or bromine water. That's the one that we use to test for saturation and unsaturated. Unsaturation, I mean. For saturation, what will be the result? If the compound is an alkane or is a saturated hydrocarbon, what will be the result? There will be no change. The color for bromine will remain brown because that's the color for bromine. It's either brown, red, or yellow, or orange. So if you add it to alkane or to saturated hydrocarbon, the color will remain the same. And for unsaturated hydrocarbon, for example, the alkyl, if you add bromine water to the unsaturated hydrocarbon, the color changes from brown to colorless. Or if it's orange, it will change from orange to colorless. That's how we differentiate between the two. And the other compound also that we can use to show this difference is potassium permanganate, which is purple in color. Again, if you are to add it to the saturated hydrocarbon, the color remains the same. There will be no change. If the color doesn't change, that means there is no reaction that have taken place. So it remains the same. While for unsaturated hydrocarbon, the color again changes from purple to colorless. Okay, so be able to tell that difference between the two. Okay, the other group that we should be able to describe there is alcohol. Know the properties of these members of the alcohol and also know them. Remember, we have ethanol, methanol, propanol, butanol in that group. Those are the members. So what are the properties? Because they are of the same family, the properties are also the same. Okay, know their structural formula and also be able to describe what will happen to the melting and boiling point as the number of carbon increases in the chain, or as the chain increases. What the length of the chain increases, what will happen to the melting point and the boiling point. Okay, then we should be able to describe the formation of ethanol and ethanoic acid. Ethanol and ethanoic acid. How is ethanol formed? I said ethanol is a member of alcohol. It's a family of alcohol. Now, how is it formed? If you want to have to make or to produce ethanol, what are the reactants that you need so that ethanol is going to be formed? There are several reactions that you can do so that you get ethanol. Then also be able to describe the formation of ethanoic acid. This is another organic group, ethanoic acid, but no matter how many members of the carboxylic acid is, how many they are, you are only required to know how one of them, which is ethanoic acid, is formed. We don't mind about the other one. That's according to the objectives in your study guide. Okay. Then the other thing that I want us to look at is the chemical reaction. Chemical reaction, we should be able to describe the factors that affect the rate of a chemical reaction. Factors that affect the rate of chemical reaction, for example, temperature, the concentration of an acid, the surface area of the solid that is going to be reacted, because here we are talking about the reaction between two or more reactant. For example, if you react a metal with an acid, so if the acid is concentrated, the reaction is going to be fast, because the more concentrated the acid is, the faster the reaction will take place. Okay, and if the concentration of the acid is low, that means also the reaction is going to be slow. Temperature, how does temperature affect the rate of reaction? Be able to describe that. The higher the temperature, the faster the rate of reaction, and the lower the temperature, the slower the rate of reaction. Surface area is another factor. You should be able to describe how surface area affects the rate of reaction. And remember, when you are talking of surface area, we are looking at the sites when the reaction is taking place. How large or how small are the sites where these particles are going to collide? And surface area have to do with the size of the particles. Size of particles, smaller size of particles have got a larger surface area. That means the rate of reaction is going to be fast when the size of the particles are small, because there are more sites where collision is going to take place. And large size of particles have got a smaller surface area. That means there are smaller sites where collision of particles is going to, or of the acid or whatever is reacting with that substance, is going to take place. So the larger the surface area, the faster the reaction. And the smaller the surface area, the slower the reaction. Apart from that, we should also be able to sketch a graph that shows how a reaction goes, how fast or how slow the reaction is. Can be for surface area, can be for concentration, or it can be for temperature. Be able to sketch those graphs, or be able to interpret the graph that involves all those factors. Okay, then the other thing that I want to talk about is the metals. And here I want to touch on the extraction of metals, in how we obtain metals from their ore. We have the extraction of iron, we have the extraction of zinc, we have the extraction of aluminium from their ore. So be able to describe the steps followed in the extraction of each of the elements. And in addition to that, you should also be able to write down the chemical equations and also the word equations. Most of the students get confused between the two. Some don't know the difference between a chemical equation and a word equation. So the difference is this. A word equation is that equation that you write using the names of elements or of compounds. So if you are asked to write a word equation, you write that equation using the names of elements or compounds that are involved in the equation. And when you are writing a chemical equation, you write a chemical equation using the symbols of the elements or formulas of the compound involved in the reaction. And that's when the balancing of the equation also comes in. When you are asked to balance write the equation and balance it, that means the only equation that you can write and balance is a chemical equation, because it's the one that shows the ratio of atoms that are involved in a compound, or that shows the number of atoms in a compound, or the number of atoms in an element or in a molecule. So be able to write the word equation and the chemical equation for the extraction of every step involved. Okay, so student, this syllabus is very huge, and what I have just stated or said here is not what is coming in the examination. It's not exactly what is coming in the examination, but it's just a highlight to help you prepare for the upcoming examination. So please spend most of your time on your studies, be focused, and work hard in order for you to achieve what you want to achieve. So thank you very much for listening to me. So if you have questions, feel free to contact me on my cell phone number 081 49 86 908, or on my email address, which is salmanangulamakili@gmail.com.